Hello everyone, and welcome to the lab on circular motion. So the first part of this lab, we have this instrument, this circular motion apparatus. And basically what we're going to do is we're going to spin it at a particular angular speed such that this hanging object here is hanging completely vertically. So right now it's up a little bit, and at some point, once it reaches the correct speed, this object will be hanging vertically. So the vertical forces, you have basically a tension pulling up here and the weight of the hanging object. Those are going to cancel out, and the only force that's remaining is the centripetal force pulling towards the center of the circle as it's rotating. So the goal here is to calculate that centripetal force two different ways. So one way is going to be theoretically using the angular speed, that information. The other way that we're going to compute it, and I'll do this first, is experimentally by balancing the forces on either side, like the horizontal forces. So to do that, basically, I'm going to connect a string to the hanging object. I'm going to go over a pulley, and then I have a mass set here, so another hanger. This is called the hanging mass in our notes. And I'm adjusting this, and I've already done this previously, so that this hanging object is exactly vertically now, okay? If you were to look, it may be hard to see in the video there, but you'll see there's like a dark black line behind this. The string lines up perfectly with that black line. So what that's saying is that the tension pulling out must equal the tension pulling in when the hanging object is vertical. So basically this tension pulling out is going to equal the centripetal force when the object is hanging vertically. So how do I figure out this tension pulling out, which is the same as the centripetal force experimental? Well, it's simply going to be the weight, right, of this hanging mass here. So this string just redistributes that tension, right, because it's passing over a pulley. So if you think about it, I have a weight pulling down, which is equal to mg, right, the mass in kilograms times 9.8, a tension pulling up. Since that hanging mass is not accelerating, that tension has to equal the weight of the hanging mass. Okay? So basically, we're calculating the centripetal force experimental by finding that weight of the hanging mass here. Okay, so that's the first part. So I give you the mass that I had to put on here so that everything balanced, and that'll be on the handout. So now let me take this off. By the way, if you noticed here, let me put this on for one more second again. When that was balanced, the other thing I did was I adjusted this bracket so that the bracket was right at that orange indicator. Why do I have to do that? Because later when I spin this, the question is, how do I know that that hanging object is completely vertical? Well, I know it's vertical when the indicator here lines up with that bracket. Okay, so that's how I know I have the correct angular speed. Okay, so to do this now, I'm going to give the little DC motor here some voltage. So I'll start with 2, need to go a little bit more than that, I think. So I'm just adjusting this finely, the voltage here, so that the speed is correct so that I know that hanging object is vertical, right? So I'm looking at the indicator now to make sure it's lining up with the bracket. So I'm going to go a little bit faster here. So right about there. So it's pretty much lined up with the bracket. Okay, so I know that the thing's vertical. So now what I'm doing is, and I'm doing 10 trials of this, I'm collecting the angular speed in radians per second. So using the smart timer, I simply press the start button. It uses the photo gate in there, and it gives me a value, in this case, 4.73 radians per second. So what I did in the handout was I collected that data. I did 10 trials, so you have 10 values of the omega, the angular speed. Okay, and then using all the information, we can compute theoretically what that centripetal force should be, and then we can compare it to what we just got experimentally. All right, let me shut this down. The other thing that you need to compute the force is the radius, right, of the circle, like when it's hanging vertically. Well, that's simply going to be 0.15 meters. That's where this bracket is located right now. So 0.15 meters is the radius. That's also on your handout. Okay, so hopefully that made sense. That should get you through the first part of the experiment that deals with this rotational apparatus.